here's just a quick like primer on the exponent rules. So this is a really useful chart where we have all the exponent rules listed that you need to know, essentially the properties, and an example of each. So for the first one, it's called the zero power. So anything to the power of 0 is always equal to 1. So you can try this in your calculator. The example here is 7 to the power of 0, which is equal to 1. If you were to say 1,000,000 to the power of 0, it would still be 1. And then we have the product of powers. So essentially when you're multiplying something with the same base, so like the a here is the same like variable, then whatever their exponent is, they're additive. So in this example, we have 2 to the power of 5 and 2 to the power of 3. So since these are the same, we can add the exponents to give us a total of 2 to the power of 8. I'm just going through these because it's really important to have a solid understanding of these and then be able to apply them in any context. And these types of questions are just really prone to silly errors as well. So you want to make sure you're doing it as accurately as possible. And so in this case, when we have a quotient of powers, so essentially we're dividing, it's similar to the product, except we just subtract the exponents. So m minus n. In this case, we have 5 to the power of 7 over 5 to the power of 3. We keep the base the same because it's the same number, or it could be a variable. And we subtract the denominator exponent from the numerator's exponent. And when we have a power of a product, it basically gets distributed. So the bracket is saying that this exponent applies to every single thing that's being multiplied within these brackets or parentheses. So here we have 2 to multiply by 6, all to the power of 3. So this can be rewritten as 2 to the power of 3 multiplied by 6 to the power of 3. Or alternatively, you could solve for 2 multiplied by 6, which is 12. And then you could do 12 to the power of 3. It would be the same number. And then for power of a quotient, when you have parentheses like this, same thing. It applies to the numerator and to the denominator. For power of a power, it essentially multiplies. So instead of adding, so if you have 3 to the power of 4 and that whole thing to the power of 2, then that becomes 3 to the power of 4 multiplied by 2, which is equal to 3 to the power of 8. And then if you have a negative exponent, this is another way of saying it's essentially kind of like a reciprocal. So it's 1 over a to the power of m. So an example is 2 to the power of negative 5 is equal to 1 over 2 to the power of 5. So this would be a positive number now, but it's just in the denominator. So that's what this, anytime you have a negative, it just means that that exponent is in the denominator of a fraction. Okay, so now let's apply these. And if you have any questions about any of these or other ones, you can send follow-up questions. But hopefully this helps. So this one now, we're going to be using the power of a product, right? Because we have brackets. And, oh yeah, sorry, I forgot to mention this rule that I mentioned previously. So essentially, if you have parentheses versus no parentheses, and you have a negative, it makes a big difference. So it's really important to keep track of the sign and the brackets. So if I had negative 2 to the power of 2 versus negative 2 to the power of 2. So now this is negative 2 multiplied by 2, which is negative 4. And this would be negative 2 multiplied by negative 2. So it's positive 4. So it's completely different. Okay, so for this, distribute the exponent to each thing within the brackets and simplify as much as possible, I believe, right? So we can write this as 3 to the power of 3, a to the power of 3, b to the power of 3, and we know that this is 27. So that's the most simplified version that we can get of this. Then for this one, and always remember BEDMAS, so that is helpful as well. But essentially, we have 4n to the power of 4. We can't really simplify that further, but we see that this variable is common to the two, right? So we can perform the operation of the coefficient. This is called the coefficient, the number in front of the variable. You might be familiar with that term, but if not, that's the coefficient. So basically 4 multiplied by 2, you can multiply the 2 because they're both like real numbers. So you get 8. And then you have these, these powers being multiplied, right? So product of powers would be this rule. So that becomes n to the power of 4 plus minus 3. So that's the kind of thing to be careful of here. You have to add them, but there's a negative sign. So this simplifies it to 8 to the 8n to the power of 1, and you don't have to write 1, so we just write 8n. Okay, so the next one. We can simplify the fraction here. These are both divisible by 3. So we can write that as 1 over 3. And then we do x to the power of 3 minus 1, because this is in the denominator, so it has a negative fraction when we try to bring it. And when we're doing the fractions, we're subtracting anyways, right? So then this becomes 2 minus 5. So when we rewrite this, we get 1 over 3x to the 2 and y to the negative 3. Remember what I mentioned about negative numbers? So when you have a negative exponent, it goes in the denominator to try and make it positive, and it's stated in the passage as well, in the question, sorry. So that is the answer for that one. And then for this one, we can't really simplify the fraction, so we'll leave that as is. And then m to the 4th minus the second power, and then n to the 3rd minus 2, p to the 3rd minus 1. So this is 4 over 3, m to the second power, and 1, and then p squared. So these are all positive, so you can put them in the numerator. Yeah. Okay. Now I think this was on the second sheet. This one is also gonna require your pre-existing knowledge of BEDMAS or PEDMAS, however you learned it. So 6 minus 8. Obviously, first we're going to tackle the stuff in the brackets, right? So 6 minus 8, we know is negative 2, and that's going to be in brackets. So we're going to do that to the power of 5, and then whatever that number is divided by negative 4. So we can, we know that since this is an odd number, this is going to be negative. And 2 to the power of 5 is 32, so negative 32. You can show your work if your teacher prefers that by like showing it, but essentially it would be like negative 2 multiplied by negative 2 like 5 times. So I won't do that. And then divide this. Oh yeah, sorry. Make sure to keep the parentheses. I forgot that, see? And then negative 4. And then since you're essentially doing negative 32 over negative 4, right? That's a way of rewriting it. You know, the negatives cancel out. So 32 divided by 4 is 8. So that's the final answer. And then for this one, we have 8 here divided by negative 2. This is simplified. And we can simplify what's in the brackets here. So 4 times 2 is 8. 8 squared. And now we have an exponent. So we can do that. 8 divided by negative 2 plus 64. Now we can do this. Sorry, 8 divided by negative 2 is negative 4 plus 64 is equal to 60. So that's the final answer for that one. And then this one, similar thing, but there's just one added step to it. So now we have 2 brackets. So we will do the first one that comes from left to right. And then there's an exponent within the brackets. And here you'll notice there's no there's no bracket in front of the negative 3. So essentially I like to use square brackets sometimes. This becomes negative 3 to the power of 4. So negative, and then 3 to the power of 4. So 3 times 3 times 3 is 27. 27 times 3, I believe, is 81. Yes. 81 multiplied by 4 minus 1, all divided by negative 5 to the power of 2. So this is just going to be 25, right? Because it's negative 5 multiplied by negative 5. So it becomes positive. And then negative 81 multiplied by 4 is equal to, I don't know what 81 times 4 is. I'll do that here. 324. So negative 324 minus 1 divided by 25. And then this becomes negative 325 all divided by 25, which is equal to negative 13. So is Henry or Gina correct? Gina would be correct. And the most likely error that the student made could be a variety of errors, but like for instance, they could have messed up the negative sign here in this step, or over here, like I mentioned, they might have assumed there were parentheses here. So instead of negative 81, they had positive 81, right? So they did negative 3 multiplied by negative 3 multiplied by negative 3 multiplied by negative 3, and then that would have given you a positive number, right? Because these two are positive and these two would be positive. So that's the most likely error, I would say, for your homework assignment, that they made an error when computing this exponent, since the unit is on exponents. But yeah, hopefully that helps.